So my next guest today is Dave Webb from a company called Seica OSI Automation. Welcome,
good.
Dave. Nice to see you.
Nice to see you again.
Yeah. So some big news this week from Seica. You got a couple of new machines out.
Brand new.
Yeah. So I believe the first of them has got a very cool name.
Yeah, it's a ISO cubed.
The Ice Cube. Yeah.
Yeah.
So
Yeah,
tell us about the Ice Cube. What is it and how does it work?
It's solutions that are integrated to infinity. You can have any combination of digital, and what we have right now is a power tester. That's the size of about 2 foot by 2 foot, and the power range at the moment is 6K, and in this particular box we are 400 amps.
Right.
And we can show this. So this tester reflects 35 years of device testing on a flying probe system, so that you have to electrically isolate all these devices. We know how to test every device you can think of. Current, back with a library of 35 years. So we decided, well, let's go ahead and use that technology and the boards that we use on the flying probe systems.
Right.
And integrate them for a single device test, and then multiply that, go parallel. So we have all this experience, but we haven't ever done it in an individual component test.
So the beauty of doing that is that you're not going to get any noise. You're going to get a true measurement.
Right. So this zero noise floor is a big deal when you're measuring very small FETs. But not so much so when you're testing a 6,000 volt MOSFET, right? Okay. So the other thing is that when you do the software in the past for analog, you didn't really have a good SPICE modeler.
Yeah.
That would sit at your desk, not at the tester. So you can put in the software and simulate your brand new device without anyone knowing the specifications. And you can sit there and run the specs up and down until you break that.
Wow.
And look at it on the built-in oscilloscope.
Right. So you can. That's wonderful.
That advantage is amazing.
Yeah. So basically, you can simulate any worst case scenario that device is likely to face.
Correct. That's right.
And really just test it to breaking point.
Yeah. So I've pointed out the three what I consider most valuable features of this design. The other is people say, well, we need to test something that requires boundary scan. We do boundary scan. We learned how to do boundary scan a long time ago with several models of that boundary scan to access an ACE.
But you do it in the same machine?
Yeah, same machine. You just change the configuration.
Right.
So.
It's flexible too then.
Yeah. That's right. That's right. And that's why we kind of say it has this kind of cube effect, because it can do all of these different varieties. And we have them in the library. We've been doing that with the flying probe for years.
Right.
35 years we've been collecting how to test parts.
Right. Okay.
Now we don't have to isolate them electrically.
Yes.
And we can do it in a high parallel environment.
Yes.
And we can use the OSI automation to integrate all of it into the SI.
Yes. Yes.
So that's
sounds like quite a step forward actually.
Yeah, it is. It's huge, and that's the cube.
Has there been a lot of excitement over it? I mean,
yes. Yesterday we had 15 big companies
really
come and take a look at it.
Wow.
The traffic at this show has just been brilliant.
It has,
and people who are serious. People have hand delivered requests for quotation.
Yes.
Yeah.
No, it is. The quality of the audience here this week is fantastic. So
I'm super happy with this show, where it is,
Yeah.
the temperature outside, so the time it is. It's just been really divine.
Yeah. So there's another machine that you brought out as well. So there's actually two new developments from Seica this week. What was the second one?
Yeah, the RTH system is a stress heat-related resistance measurement tool to automate what's typically done in the engineering lab by groups of engineers in different ways. A customer approached Seica and said, look, we would like for you to automate this. We would like for you to run these tests over and over. So it's cycling at
So
a high current.
Thermal cycling.
Yeah, thermal cycling
Yeah.
with the access of 1,200 amps.
Wow.
So we're putting some power to it. The point is we're trying to break it. So people have specs. And when you're doing a competition for a design-in, they're looking at these specifications and say, how long is this device going to last? How tough did we build it?
Yeah.
If you can prove, and we gather all the data, all these repetitive tests over and over for months, it can be perpetual. At the stress level that you prescribe, and this company prescribed one, said, look, do it this way. So it's a proven technology. And they said, now just make a bunch of them. So we did. And we have the capability to do the testing, and we can damn well measure it, and we can store that data. They can prove that they're the best in the market. They have the information.
They've got a competitor advantage then.
Yes, and that they can prove.
Yeah.
Right? So
Excellent.
it's a powerful tool.
Absolutely.
The value there is really winning design-ins.
But I mean, but that appeals to the people who are manufacturing the semiconductors. That's the market for that, really.
Yeah, if you're using power devices, you want to be sure that it works reverse and forward, whatever you have built to, whatever that spec is for that tractor or that car, or that train.
Yeah.
It better work when you throw it in the reverse, and it better not blow up when you throw it in the reverse. Over and over again, right? So you go back forward, reverse, different speeds. This IGBT or this power FET is going to really rely on that supplier to have gotten it right.
Yeah.
When it breaks, it's a bad thing.
Yeah.
The train stops, so people have to get off, all that.
Yeah.
So it's I consider it an extremely valuable tool. Probably could be used by every manufacturer of high power devices.
Right. Wow. Well, that's two really important innovations in 1 week. So congratulations, and
Thank you.
thank you for coming in and telling us about it today.
Well, you're welcome. And one thing to remember is we work with OSI Automation, which is just down the street, 50 minutes away, in Italy, to integrate all of this automation to these testers.
Yes.
So,
yes.
and that,
Great partnership.
It is.
It is. Great.
Thanks a bunch for having me.
Thank you.